You've been there, right? You write this piece of Apex code, it works perfectly in your sandbox, and then it just completely crashes and burns in production. It is a total developer nightmare. Well, today we're going to talk about how to build smarter, much more resilient code that actually sees those crashes coming and, avoids them. So let's get into it. I mean, you've done everything by the book. Your code is clean, all your tests are passing, it handles your sample data like an absolute champ. But then, the second it hits the real world with real users, and more importantly, real data volumes, it just fails. It's a super frustrating and really common story. So what is actually going on? Well, it's because your code is running full speed into a hidden wall. It's this invisible barrier that you just don't see during development, but it can bring your entire transaction to a screeching halt. Now, this hidden wall, it actually has a name, and it's a concept that's absolutely fundamental to Salesforce development, governor limits. And understanding these is really the first big step to building apps that are truly robust. The easiest way to think about governor limits is like a really strict budget for your code. See, Salesforce is what we call a multi-tenant environment. We're all sharing the same resources. So the platform gives every single transaction a fixed allowance for stuff like database queries, processing time, and memory. It's what makes sure that one person's runaway code can't slow down the whole system for everybody else. And here's the real kicker. If your code goes over that budget, there's no warning. The entire transaction doesn't just slow down, it just fails completely. It's this all-or-nothing approach that leads to those awful unhandled exceptions, weird data issues, and a really bad time for your users. But what if you could see that wall coming? What if you could avoid hitting it altogether? What if your code had its very own fuel gauge? Well, this is exactly where a super powerful built-in tool comes into play, the Apex Limits class. This right here, this is the big shift in mindset we're talking about. Instead of just flying blind and kind of hoping you don't run out of gas mid-flight, what if your code could be smart enough to check its own fuel tank before it takes off on a long journey? And the Limits class is exactly that tool. It's built right into Apex, and it gives you these really simple methods to ask the system two critical questions. First, hey, how much of my budget have I already spent? And the second, what was my total budget to begin with? So how do we actually read these dials? Let's get practical and look at the methods you can use to keep an eye on your code's resource consumption, in real time. Okay, just picture this. You're in the middle of a big, complex transaction. You've already used 95 of your 100 allowed SOQL queries. You are deep in the danger zone. And without checking, your very next block of code could easily push you right over the edge. This is the exact situation the Limits class is designed to prevent, because it lets you get both of these numbers, the 95 you've used and the 100 you're allowed. So these are the actual dials on our fuel gauge, and you'll notice a really clear pattern here. For every major resource, like SOQL queries or DML statements, there are two key methods. There's a get method, like get queries, that tells you your current usage, and then there's a get limit method, like get limit queries, that tells you your total allowance. It's a really simple but incredibly powerful pairing. All right, so we know what the tool is and we know how to read the dials. Now let's actually put it into practice with a super common and really critical scenario I like to call the pre-flight check. Let's imagine you've got a trigger that fires when records get updated. Now, sometimes it's just one record, but sometimes it's 200 records coming in from a big data load. The amount of work your trigger has to do is totally unpredictable. That is a prime candidate for running into limits and a perfect place for us to use a pre-flight check. The logic for our check is actually pretty straightforward. First, we just ask, how many queries have we already used? Second, we find out what the total limit is. Third, and this part is absolutely key, we define a safety margin. We don't want to wait until we're at 100%. We want to know if we're getting close, say at 95%. And then finally, we just perform that check. And here's what that logic looks like in real Apex code. It's simple. We just call limits.getQueries and check if that number is bigger than or equal to our total limit minus our little safety margin of, say, 5. If that condition is true, boom, we know we're in the danger zone, and now we can take some kind of smart alternative action instead of just letting it crash. Okay, so our pre-flight check has raised a red flag. The code has spotted that hidden wall up ahead. So what now? This is the crucial part. This is where we go from just writing code to actually architecting smart, resilient solutions. The difference here is honestly, it's night and day.
The old, reactive way is just to let the code run until it smacks into that wall and causes a big, ugly, unhandled exception. The whole thing fails. The smart, proactive way is for the code to see that wall coming and adapt its behavior before it becomes a crash.
And what does adapting actually look like? Well, you've got options. You could just gracefully stop the really resource-heavy part of your code. Or you could log a warning for an admin to look at later. A really powerful pattern is to flag the rest of the records to be processed later by an asynchronous job, since that gets a whole new set of limits. Or hey, you could even throw a custom exception to tell the user that, some of the work got done, but not all of it. And that's really the core idea here. It's all about making a choice, the choice to handle things gracefully, instead of just letting them fail abruptly. When you monitor your limits, you're building systems that can handle stress and unpredictable loads without just falling over. You're building for the real world.
And that, at the end of the day, is the real takeaway. Look, any developer can write code that works on a single record, but a great developer writes code that actually scales and stays stable under pressure, no matter how much data you throw at it. And using this technique is a huge step in that direction. So, as we wrap this up, I'll just leave you with this one question. Think about the triggers, the batch jobs, the complex services you've written. What is one part of your code that you can go make smarter, more resilient, and way more professional by adding a pre-flight check today? Thanks for listening.